Feeling scattered. Can all data be plotted and graphed on a coordinate grid as neatly as in the functions below? In this lesson, you will extend your thinking about graphing data by looking for relationships between data that cannot be described by a specific function rule. Since elementary school, you have focused on univariate data. Univariate data is data that represents only one variable. Here are some examples. The heights of NBA players, the amount of rainfall, and gasoline prices. You've just seen some examples of graphs of how univariate data can be displayed. This year, we began analyzing data with two variables. This kind of data set is known as bivariate data. Bivariate data is data that represents two variables. And here are some examples of bivariate data. The number of students in a school and the yearly budget for a school. The number of hours that students study for an exam and their score on the exam. Notice that in both of those examples, the two variables are being compared. How can you remember the difference between univariate and bivariate data? Well, the way I remember the difference is I look at the prefix uni in univariate and bi in bivariate. Uni means one. Think of a unicycle. It has one wheel. Bi means two. Think of a bicycle. It has two wheels. So univariate means one variable, and bivariate means two variables. So to visually represent bivariate data, we use what's called a scatter plot. A scatter plot is a graph with points plotted to show a possible relationship between two sets of data. So together, why don't we create a scatter plot? This is the guided practice. The table shows the number of cookies in a jar from the time since they were baked. Graph a scatter plot of the data. So let's look at this table. We see time since baked. In parentheses we see D. What do you think D stands for? I'm thinking D stands for days. So after 1 day there were 18 cookies in the jar. After 2 days there were 16 cookies. After 3 days there were 10, and after 4 days there were 7. So we have to plot these 4 points on this grid, but before we can do that we need some information on this grid. First thing I'm thinking is the time since baked would be the x-axis because time is always independent. So right away I'm going to label my x-axis time since baked, if you could see that on the bottom. After I do that, I see that I have the points 1, 2, 3, and 4. Those 4 values need to be on my x-axis. So I want to spread them out evenly. So you'll see what I have here, 0, 1, 2, 3, and 4. 0 should always be at the origin. And then I counted 4 spaces, put a 1, counted 4 spaces, put a 2, 4 spaces, put a 3, and 4 spaces, put a 4. I'd like you to copy this down on your handout. Since we use time since baked as the x-axis, or as the independent variable, we'll use the cookies in the jar as the dependent variable, and that will go on the y-axis. And I see that my biggest value in my y values is 18. So I know that I need to go up to 18 in my grid. If I count 20 lines, 20 intervals all the way to the top. So I'm going to go up by 1, so that'll be looking like this. Now's the fun part. This is when we get to actually plot the points. So the first point I want to plot is 1, 18. 1 on the x-axis and 18 on the y. I'll plot that point right there. 2, 16 should be right there. 3 on the x and 10 on the y should be right there. And 4, 7 will be plotted there. So 7 is the only one that you don't see the 7 on the y-axis, but it's there. It's in between the 6 and the 8. We need one more thing on this graph, and what do you think it is? A title. So we'll call it the cookie jar. So now I'd like you to turn to the back of the worksheet and you'll see 3 scatter plots. We're going to talk about these a little bit. Scatter plot relationships. A correlation describes a strong relationship between 2 sets of data. A scatter plot may show the type of correlation. So here are those same 3 scatter plots that you see on your worksheet. And these 3 scatter plots show some type of correlation. If you see in the first graph, we see the points are kind of working their way upwards. So as the x values are increasing, the y values are also increasing. It's kind of like the slope of a line. So if you saw a line working its way upwards, what kind of slope would that line have? We call this a positive correlation. I'm sure you could figure out the next one. As the x values are increasing, the y values in this case are decreasing. So we call this a negative correlation. Now this last scatter plot looks kind of weird. Do you see a trend of all the data increasing or decreasing? I don't. I'm seeing it very scattered. And when you don't see a trend, if the data is increasing or decreasing, we actually say that there's no correlation. So this one has none. I'd like you now to identify the type of correlation from the cookie jar scatter plot that you graphed on the front of the handout. Does it have a positive, a negative, or no correlation? If you said a negative correlation, you'd be right, because as the time increases, the number of cookies decreases. So as x increases, y is decreasing. That represents a negative correlation. Okay, I think it's time for you to try it on your own. So here's your example. Neil kept track of the number of minutes it took him to assemble sandwiches at his restaurant. The information is represented in the table below. Here's the table. Notice that the 5 values for the minutes are missing on your handout, so you'll need to fill in those 5 values. And then I'm going to ask you to do 2 things. Number 1, graph a scatter plot of the data, just like we did in the guided practice. Included in that is labeling your axes, creating your intervals, giving your graph a title, and then of course plotting your 5 points. Then when you're done with that, I'll ask you to identify the type of correlation that you see. Remember, is it positive, is it negative, or are you not seeing a correlation at all? Pause the video, and when you're done, you can press play to check your answer. Are you ready to check your answer? Here it is. So in this table, the variables were actually switched around. The minutes, remember, is time, and time will always be independent, so that should always be on the x-axis. The number of sandwiches in this case, even though it's written first, would be on your y-axis. If you had spread your intervals apart a little bit more, that would be absolutely fine. In fact, the way I have it represented is probably too squished. Make sure that you labeled your axes, you gave your graph a title. It doesn't have to be the same as mine. And then when I asked you to identify the type of correlation, you should have seen that this was a positive correlation, because as the number of minutes increases, the number of sandwiches also increases. So you see a positive or an increase trend. How did you do? Now I'd like you to take a minute and think about some of the big ideas presented in this video. What do you want to remember? Pause the video and jot some of these ideas down in the "What's the big idea" box. When you're ready, you can press play. In the box below that, you see the word prediction. So here's my question. How can we use a scatter plot to make a prediction? What's your prediction? We'll talk about this tomorrow. In this lesson, you have extended your thinking about graphing data by looking for relationships between bivariate data displayed in a scatter plot. I look forward to extending our thinking even more tomorrow. See you then. Good night.